Assalamu alaikum everyone. Welcome to another video of Chemistry with Sarab Tasambek. In this video, we are going to look at the third type of bonding, which is metallic bonding. We have studied ionic bonding up till now and covalent bonding. Let's look at metallic bonding. One very important thing to understand while studying metallic bonding is that metallic bonding doesn't happen between two metals or more than two metals. Metallic bonding happens within a metal. So metallic bonding will be there within the sodium metal, or metallic bonding will be there within the magnesium metal, or metallic bonding will be there within the iron metal. It doesn't happen between two metals. Metallic bonding happens within a metal. So let's define what is metallic bonding. Metallic bonding is basically defined as the electrostatic attraction between positive ions, in a giant metallic lattice, and the sea of delocalized electrons. This is the definition of metallic bonding and can show up in the exam. So you need to memorize this. And the sea of delocalized electrons. Now, since we have studied that metals tend to lose electrons, so what will they do is, within the structure of a metal, the atoms of a metal will lose their outermost electron. So for example, sodium will lose one electron per atom and will get a positive one charge. So the representation of metallic bonding is something like this, which is drawn in front of you. These are positive ions. And how are these positive ions formed? These positive ions are formed when the metal atoms have lost their outermost electrons or valence electrons. These valence electrons are delocalized. When I say delocalized, that means these electrons are free to move. So C of, and I'm saying C because there are plenty of electrons. So C of delocalized electrons. Delocalized electrons means they're free to move. They can move throughout the structure. C of delocalized electrons. Now, when we talk about metallic bonding happens within metals, right? And when we talk about the properties of metals, so when we talk about properties of metal, the first property of metal would be that metals conduct electricity. And again, why do metals conduct electricity? Because they fulfill the condition of electrical conductivity. That is because metals have free moving delocalized electrons that can carry the charge. Free moving delocalized electrons that can carry the charge. So metals are good conductors of heat and electricity. Why are they good conductors of heat? Metals are good conductors of heat for the very same reason that they have free moving electrons, which will convert the heat energy to kinetic energy, and these electrons can transfer heat from one side of the metal to another. So metals conduct heat for the very same reason, because the free moving electrons convert the heat energy into the kinetic energy of electrons. That carry the heat energy from one side to the other. The next property we need to understand for metals is that metals are malleable and ductile. When we talk about the term malleable, malleable means that can be hammered into different shapes. Hammered into different shapes. Why are metals malleable? Because when I apply a force on one layer of the metal, right, these layers can slide over each other. So when I apply force, this layer will move forwards and this layer will stay as it is. So metals are malleable, hammered into different shapes because the layers of positive ions can slide over each other. Layers of positive ions can slide over each other. And then metals are also ductile. What do I understand by the term ductile? Metals are ductile, can be drawn into wires. Can be drawn into wires. Why are metals ductile, can be drawn into wires? For the very same reason that the layers can slide over each other and I can cut the metals into its different shapes. So metals are ductile and can be drawn into wires. Now, one thing I need to understand is when I use the definition of metallic bonding, I have used the term giant. By giant, I mean that all metals will have a giant structure. And it's a giant metallic lattice. Again, lattice here would be a regular arrangement of positive ions surrounded by a sea of delocalized electrons. So ionic compounds, all giant. Covalent compounds can be simple, can be giant. Giant covalent compounds we have studied, diamond, graphite and silicon dioxide. And metals have all a giant structure. So when I use the term bonding, ionic, covalent, metallic, when I use the term structure, simple or giant. Metals all have a giant metallic lattice. So this is all about metals, and in the next video, we're going to start our new chapter, that is equations, balancing equations, moles and stoichiometry. So till then, thank you very much everyone.